At the heart of the AI boom, each chatbot reply burns more electricity than you would guess, and training the latest models costs over $100 million, more than powering some countries. Yet while investors chase sky-high promises, tens of thousands quietly earn dollars a day labeling data from Nairobi to Manila. If the math behind this new gold rush does not add up, why is no one sounding the alarm? This is how belief overtakes reality, and what happens next will rewrite more than markets. On the balance sheets of the world's leading AI labs, numbers tell a story that hype cannot drown out. Training a single frontier model, like GPT-4 or Gemini Ultra, demands a budget that can rival the annual spending of a small nation. OpenAI's latest large-scale run topped $78 million just for compute, with Google's Gemini Ultra reported at nearly $192 million. These figures are only for the hardware and cloud time. They do not include the salaries of hundreds of engineers or the cost of failed experiments along the way. When all expenses are totaled, research and development, infrastructure, power, and water, the real bill climbs even higher, sometimes past $500 million for a flagship release. The energy appetite is relentless. A single training run for a top model can draw more than 20 million kilowatt hours, enough to power tens of thousands of homes for weeks. Meta's Llama 3 clusters in Oregon have drawn so much electricity that local utilities measure their impact by the megawatt, not the light bulb. Water use is just as staggering. Cooling the racks for a multi-month training campaign can require tens of millions of gallons, sparking public hearings in places like the Dalles and Mesa, where city councils debate whether to ration water between residents and server farms. Once the model is trained, the costs do not stop. Each time someone chats with an AI, asks a question, or prompts a new image, the underlying servers spin up, burning more energy and racking up more bills. For the largest models, a single query can cost several cents in raw compute, multiplied by millions of users every day. Subscription fees and ad revenue rarely cover the outlay. In 2025, OpenAI reported $4.3 billion in revenue and $13.5 billion in net losses in just 6 months, a gap that no amount of user growth could close. MIT found that 95% of companies deploying generative AI saw no measurable value, only mounting expenses. Cloud providers and chip makers, meanwhile, have become the gatekeepers. Microsoft, Google, and Amazon each invest billions annually in new data centers, hoping to keep pace with demand. But as hardware shortages and power constraints bite, contracts are renegotiated, and spot prices for GPU time can double or triple overnight. Even the most optimistic financial projections now acknowledge a hard reality. The economics of large-scale AI are dominated not by clever code, but by the cold, unforgiving math of hardware, energy, and infrastructure. Every new breakthrough comes with a bill that cannot be wished away. In a quiet office block on the edge of Nairobi, rows of young workers stare into glowing screens, their hands moving in steady rhythm. Each click, each highlighted box, each flagged sentence is another lesson for a machine learning to mimic the world. The promise of artificial intelligence, fast, frictionless, automatic, rests on this invisible human layer. 8-hour shifts stretch into 10-hour days. In Manila, in Mumbai, the pattern repeats. Headphones on, eyes fixed, fingers tagging, sorting, correcting. For every chatbot that answers politely, for every image that gets a label, there is someone earning between $1 and $3 an hour, often with no contract, no benefits, and no guarantee of tomorrow's work. The platforms call it opportunity. The workers call it survival. Tasks are measured by the thousand. Some labelers process up to 1,000 images or sentences each day, racing quotas set by distant algorithms. The jobs are repetitive, but the content is anything but predictable. One moment, it is photos of street signs or animals. The next, it is hate speech, graphic violence, or images no one should have to see. There is no warning, and there is almost never any counseling. Some labelers describe the sensation of their minds being automated alongside the data, becoming numb, detached, or anxious. Every click I make, I wonder, does anyone know this isn't magic? Says a worker in Nairobi. Another in Manila admits, Sometimes it feels like my mind is being automated along with the data. Yet for all this labor, there is little recognition. The public story is one of seamless automation, of machines teaching themselves. But the reality is that these workers are the teachers, the silent backbone of the AI revolution. Their contributions are measured in gigabytes, not gratitude. Most will never see their names in a press release or a product launch. We make the AI look smart. Nobody sees us. This is the contradiction at the heart of the industry. The dream of self-learning machines is built on the backs of millions who remain unseen. Automation, for now, is still deeply human. And as the demand for labeled data grows, so does the quiet cost. Paid in time, in dignity, and in the unseen toll of minds asked to filter the world's worst, one label at a time. On the other side of the world, a single chip sets the pace for an entire industry. NVIDIA's H100, once sold for under $30,000, now fetches more than $45,000 on the gray market, if you can find one at all. Official distributors run dry, and a shadow supply chain steps in. Brokers in Dubai, Hong Kong, and Central Asia move pallets of graphics processing units through encrypted channels, their shipments tracked by nothing but a telegram ping and a briefcase of cash. In sanctioned states and cash-strapped startups, these chips arrive in white vans, each one a passport to the next generation of AI. The bottleneck is not just price, it is power. Governments pour billions into subsidies, racing to build new fabrication plants from Arizona to Dresden. Export controls tighten, and the world's most advanced silicon becomes a geopolitical bargaining chip. Whoever controls the flow of graphics processing units controls the future of intelligence. Analysts repeat the line, controls the future. The numbers back it up. NVIDIA alone holds more than 80% of the high-end AI chip market, and its market capitalization surpasses $5 trillion, more than the GDP of most countries. But hardware is only half the story. As the world's best data gets scraped, tagged, and exhausted, a new problem creeps in. To keep models growing, engineers turn to synthetic data, machine-generated information, built by recycling the outputs of other models. At first, it seems like a clever fix, but each time a model learns from its own reflection, accuracy slips. Benchmarks show that after just 2 cycles of synthetic retraining, performance can drop by more than 17%. In text, facts blur. In images, details fade. Error compounds error, and the model's confidence grows even as its grasp on reality weakens. It is like breathing your own exhale, comfortable at first, then suffocating. Inside the labs, data scientists watch for warning signs. They know that as synthetic data rises, so does the risk of catastrophic drift. The illusion of endless progress starts to fracture, not with a bang, but with a slow statistical decay. The ceiling on growth is not just financial, it is physical and mathematical, and it is closing in from all sides. Cloud invoices arrive like storm warnings, lines of numbers, each one higher than the last. In 2025, some AI startups watched their monthly bills triple without notice, as GPU shortages and spot market rates surged overnight. A founder in San Francisco wakes to an email. The cloud provider's discount is gone. The next invoice is $9 million. The board scrambles for a solution, but the math is relentless. Hours later, a venture firm calls to claw back its term sheet. The funding round, once a sure thing, dissolves over a weekend. Contracts are voided, projects freeze mid-flight, and engineers stare at paused dashboards, waiting for a signal that never comes. Across the industry, the language shifts. Executives who once promised delivery dates now offer only roadmaps. Revenue projections are replaced by cost-cutting plans. Investors demand break-even points, but the answers are lost in jargon. On Slack and in boardrooms, the mood turns from euphoria to calculation. The difference between hype and reality grows impossible to ignore. A montage of past bubbles flickers through the timeline. Amsterdam, 1637, as tulip bulbs trade for fortunes until buyers vanish. London, 1720, when South Sea shares collapse into panic. New York, 1929, as ticker tape stops and the market freezes. Silicon Valley, 2000, as .com logos flicker out. Crypto, 2018, as coins lose value in a week. Each time, the moment arrives not with a bang, but with a hush. The market does not crash, it holds its breath. In the AI sector, layoffs begin quietly, funding rounds evaporate, and the dream pauses at its brightest peak, suspended in a silence that feels endless. Right now, AI shapes decisions in courts, hospitals, and classrooms, even as its foundations grow fragile. When faith outpaces fundamentals, risk shifts quietly from markets to daily life. If trust collapses, it won't just be investors who pay. Sometimes, the cost of belief is measured in what we can never reclaim.